Welcome to the Unit 9, Section 4 video on transformations of exponentials. Any exponential function with a different rate of change, a different y-intercept, and/or decreases instead of increases is simply a transformation of the parent function. The form f of x equals ab to the x minus h plus k gives us hk, the translation of 0, 1, the y-intercept from the parent function. Okay, so our h tells us how far left or right that y-intercept moved, and the k tells us how much we go up and down. You can actually identify that by looking at where your asymptote moves from the x-axis. So let's talk about the exponential transformation rules. They work just like they do for linear and quadratic functions. A horizontal translation to the right is when h is positive, but because it follows a minus sign, it's going to look negative in the exponent. So you've got something like 2 to the x minus 2. A horizontal translation to the left is when h is negative. And because we are subtracting a negative, it becomes a positive, so it's going to look like 2 to the x plus 2. A vertical translation up is when k is positive, so you'll have something like 2 to the x plus 4 outside of the exponent. Vertical translation down is when k is negative. We have a minus 4 on the end. So again, you notice that the k value is your horizontal asymptote, so you can use your horizontal asymptote where it moves from the x-axis to gauge what your k value is. Reflection across the x-axis occurs when a is negative, so you'll have a negative out in front. But you can also have a reflection across the y-axis with an exponential function. That happens when x is negative, and the negative will be in front of the x in the exponent. A vertical stretch occurs when a is greater than 1. So, for example, 3 times 2 to the x. And a vertical compression happens when a is between 0 and 1. So, for example, 1/3 times 2 to the x. So let's identify the transformations that occur from the thin exponential to the thick exponential. So our thin exponential is our parent function, and we're going to see what transformation occurs here. Well, our horizontal asymptote goes from y equals 0 to y equals negative 3. So we have translated down 3 units. For b, our horizontal asymptote has not moved, but we have shifted that y-intercept to the right by 5 units. So we have translated right 5 units. Here we have the exact same graph, but it's just reflected across the x-axis. And then for D, we have a graph that still has a horizontal asymptote of 0, so it hasn't moved up or down. You might want to say that it has translated to the left, but more appropriately, look at where your y-intercept is. It's moved from 1 to 3. So if we multiply 1 by 3, then we have stretched it by 3. So instead of having a 1 out in front, we now have a 3 out in front of our equation. So we have a vertical stretch of 3 in this case. Let's take a look at equations. Here, it's a little bit more straightforward to identify. We'll go from left to right. The 4 out in front tells us that we have a vertical stretch of 4, and the minus 5 on the end tells us that we're translated down 5 units. So notice your b value does not impact your transformation. In fact, your parent function in this case would be 3 to the x. For b, your parent function is 2 to the x. So the 3 out in front tells us that we have a stretch of 3. And the plus 1 in the exponent tells us that we have translated left 1. For this one, we have a minus out in front, so we have reflected across the x-axis. We have a vertical stretch of 8. For D, we have a 2 out in front, so we have stretched by 2. We have a minus 3 in the exponent, so we have translated right 3 units. And a plus 4 on the end tells us we have translated up 4 units. The negative out in front tells us that we're reflected across the x-axis. The 1/2 tells us that we are compressed by 1/2. And there are no other transformations on this one. And then finally for f, the 6 out in front tells us that we are stretched by 6, and that is the only transformation that occurs. To write an exponential function from a graph, identify the horizontal asymptote. This is your k. Find the point nearest the horizontal asymptote. The x value of the point is h. And determine how many units the point is away from the horizontal asymptote. This is a. Using the given parent function, plug a, h, and k back in without the values plugged in for x and y. So let's write the equation of the transform function given the parent function. So here we have a graph of an exponential. Our k is 5. Our h is 0 because the point closest to the asymptote is on the y-axis. And our a is 1. So we have the equation y equals 2 to the x plus 5. For b, we have k is 0 because our horizontal asymptote is at 0. It's on the x-axis. Our h is also 0 because the point closest to the asymptote is along the y-axis. It's still on the intercept. And a is -1 because this is reflected. So we have y equals -2 to the x. For c, we have k equals 0 because our asymptote's along the x-axis. H is 5 because if we look at the point closest to the asymptote, it's 5 units to the right of the y-axis. And our a is 1. So we have y equals 2 to the x minus 5. For d, we have a horizontal asymptote at 4, so k is 4. The point closest to our horizontal asymptote is along the y-axis, so h is 0. And our a is -1 because we are reflected across that asymptote. So we have y equals -2 to the x plus 4. And then finally for e, our horizontal asymptote is at 2, so k is 2. Our h is -4 because the point closest to our asymptote is 4 units to the left of the y-axis. And a is 1 because we are not reflected. So y equals 2 to the x plus 4 plus 2. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.